Hello chicos, today we're gonna do lesson B. Remember that these two lessons are a big review on different subjects on geometry, and today's review is on perimeter, area, volume, surface area, and sectors of circles. The first thing we have to remember is that perimeter is the distance around the figure. It's when we add all the sides, the measurements of the sides. So in this case, if we want to find the perimeter of this quadrilateral, we have to add 2.5 plus 3 plus 4 plus 6. And that would be 19.5. They don't tell us the units, but since they are linear units, let's just say that is centimeters. Okay? Now remember that circumference is the perimeter of a circle. And circumference has a formula. Is circumference equals diameter times pi. Now, where do we get that formula from? Remember that if we measure the diameter and with a string, starting to see how many times does it fit in the circumference. So let's say that's one, here's the other one, and a third one. And then there's a little bit more. And that is what pi represents. 3.14 that you guys have learned before is how many times the diameter fit into the circumference. So it's 3 times and a little bit more. Now remember that we also have the formula in radius, and so 2r pi is the circumference formula, but in terms of the radius. And why is that? Because 2 radii is the same as 1 diameter. So that's why we can use either of those two formulas. So let's continue with the next one, and then we'll do exercises on these. Then we have the area. Remember, the area is the surface inside of the perimeter. So it's this part inside of these shapes. Now we have formulas that you guys have learned in previous years. The formula for the square is L square, or the side square. Then we have the formula for the rectangle, which is the length times the width. The length is the long one and the width is the other one. Now remember, you can make yourself a little formula sheet so that you have all these formulas together. Now for the triangle, we have the formula, which is base times height divided by 2. Notice how I put base and height with lowercase. These triangles, they're all different. We have an acute one, which if that's our base, this is the height. Remember that the height is always a perpendicular line that goes from the vertex opposite to the base to the base. In this case, that is a right triangle. Here's our base and here's our height. Let me write the H and the B. This is the H and this is the B. Then on an obtuse triangle, we have the base, and then the height is on the outside. It's an external height, but it's also perpendicular to the base, and that would be the H. So it's the same formula, we just have to be careful on how we look for the base and the height. Now finally, the area for a circle is going to be the radius square pi. Okay? So let's see how we do this example B.1. It says find the perimeter and the area. So for the perimeter, we have to add all of the straight sides. So in this case, it will be 4 plus 5 plus 7. But then we also have to find the measurement of this semicircle, or that curve there. And that's very easy. It's just the radius times pi. Radius, which in this case is 2 times pi. So I'm going to put 7 plus 2 pi. And the exact answer is going to be 16 plus 2 pi. If I want to find what is the approximate answer, then what I'm going to do is I'm going to add, first I'm going to multiply the 2 times the 3.14 and then add the 16. So 6.28 plus 16 is 22.28. Now again, that's an approximate answer. So this is the approximate answer, and this one is the exact answer. Now for the area, we're going to do exactly the same. We're going to find the Now the second part is to find the area. And to find the area, we're going to divide the figure into 3 shapes. We have a semicircle, a rectangle, and a triangle. And those are the areas we're going to find: the semicircle, the rectangle, and the triangle. And so we use the formulas. Remember, for the semicircle, it's going to be r squared pi, which is the area of a circle, but divided by 2. For the rectangle, it's length times width. And for the triangle, it's base times height divided by 2. And now we just have to substitute the values given. So the radius is 2, so 2 squared pi over 2 plus the dimensions of the rectangle are going to be 4 by 4 because this is 2 and 2, so it's 4 by 4. Now remember, the 7 is it's all the way from here to here. So we actually have to subtract 7 minus 4 to find this one. So 4 by 4. And the base of the triangle is 3, and the height is 4 again, because it's the dimension of the rectangle. And that one divided by 2. And then if we just find that, that's going to be 4 divided by 2 is 2 pi plus 16 plus 6. And then remember, we have to add the like terms, which is going to be 22 plus 2 pi. And then the units, we don't have, they don't give it to us, but remember that area is square, so let's say square meters. In example B.2, we have to find the area of the shaded portion. Now notice that we have a rectangle, so we first have to find the area of the rectangle, and then we have to take away the area of the circle and also the area of the triangle. So I'm just going to put my formulas so that we can help ourselves. So we have the length times the width for the rectangle, the radius squared pi for the circle, and the base times height divided by 2 for the triangle. So the area of the shaded portion is going to be 10 times 15, which is the length and the width here. Then the radius square, which is 4 squared pi, minus the base times the height, which is 5 times 6 divided by 2. And if I simplify that, that's going to be 150 minus 16 pi minus 15. And then I only do what they are like terms, so I can only subtract the 150 minus the 150 minus 15, which is 135 minus 16 pi. And again, this, since it's area, let's say we were going to put centimeters. They don't give us the units, but let's say centimeters square. And again, I'm just going to stay with the exact answer. We don't need to multiply times pi. That is the exact answer, and that's how we're going to give it. Now we go with volume. Volume is the capacity of a 3D solid. Okay, so it's not just the surface, but it's something that goes inside of a solid. And the general formula for both prisms, and if you don't remember what prisms are, you need to make sure we go back to that, but we'll be talking about these. Prisms and cylinders, the general formula is area of the base times the height. So example B.3 is actually really easy because they're giving us the area of the base and they're giving us the height. Now notice height is with capital H because it's talking about the height of a solid, not the height of a triangle. So if I want to find the volume, I just have to multiply the area of the base, which is 242, times the height, which is 10. And that's an easy multiplication, is 2,420. In this case, they are giving us the units, which is m, and since it's volume, 3 dimensions, then we put the units to the cubic power, so m to the third power. Now in this other one, they're giving us the volume of a cone. Now, a cone and a pyramid, it's a little bit different because as you can see, there's only one base. So the capacity is actually smaller. So the formula is very easy. It's the area of the base, just like in the other ones, but now divided by 3. So in this case, I just have to use the formula and say 242, which again is the area of the base, times the height divided by 3, which will be 2,420 thirds, or an approximate answer can be 806, and 6 repeating. And since they don't give us the units, but let's assume it's the same as before, and it's volume again, so we'll put it to the 3rd power. The next thing that they ask in example B.5 is to find the volume of a sphere. A sphere is like a ball, right? The formula is this one given here. So all we have to do is use the information given, the R, which is 3 centimeters, in the formula. So it's 4 thirds times the 3 to the 3rd power pi. And in that case, it's going to be 27, because 3 to the 3rd power is 27, divided by 3, that's 9, and 9 times 4 is 36 pi. And again, the units to the 3rd power. Then we have surface area. The surface area is the sum of the areas of all the faces. And for prisms, specifically, and for cylinders, the formula is this one. Okay? So it's 2 times the area of the base. Why? Because we have 2 bases. We have this base and this one, which is a triangle. Now remember that the way to know which one is the basis in a prism is that the bases are always parallel. So you have to look for the sides that are parallel. Okay? Plus, the other thing is that the faces that are not bases, they're always going to be rectangles in a prism. So, as you can see here, everything else is a triangle. We have a triangle here, we have a triangle on the bottom, and we have a triangle on the back. So those are the yellow faces are the lateral, and then the other ones are the bases. This one is the base. Now again, notice it's capital B, bases. Okay, so let's use the formula with the information given. So first we have to find 2 times the area of the base. Now as we said, the bases are triangles, so the formula is B times height divided by 2. Remember, lowercase. Plus the perimeter of the base, which is just going to be adding let me put here perimeter of the base times height. Now all we're going to do is add the sides of the triangle. So we have, let's go here, the base times the height, in this case is going to be 3 times 4 over 2. And then the perimeter is going to be 3 plus 4 plus 5 times the height, which is 6. And again, the surface area then is going to be here. If we multiply and divide, it's going to be 12 plus, and then the perimeter here is 12 times 6, 72. And if we add these two, it's 84. Now, this is area. Surface area is area. So our units, let's say, again, that is centimeters, are going to be square because area is 2 dimensions, so it is square. Now, they ask for the surface area of a cylinder. And again, it's very similar. It's 2 times the area of the base. But in this case, we have a very specific formula for the base. It's r squared pi, because it's a circle. And then we also have a very specific formula for the perimeter of the base, which is circumference, 2r pi times the height. And then we just use that formula. Again, you could write that in a formula sheet. But then we just use that formula by substituting the points. So we have 4 squared pi plus 2 times 4 times pi, and then the height, that is 10. And in this case, we have 4 squared is 16 times 2 is 32 pi. And then 2 times 4, which is 8 times 10 is 80 pi. And since they both have pi, we can add them. And the answer is 112 pi. And again, they don't give us the answers, but let's say it's meters and area is square. This has a lot of examples. So let's look at example B.8. In this case, we have to find the surface area of this cylinder that is 10 feet high. Notice that the base, this is the base, capital B, the base of this cylinder is irregular. It has some straight sides and some curves. So we have to be careful and find the area with the formulas that we've learned. So what we were going to have to do, notice that this part here is this part here. That's your base, okay? So that you see what's happening. They give you the base on the side so it's easier to work with. But anyways, if we divide that, we're going to use the same formula. It's 2 times the area of the base, which in this case is a rectangle, plus a semicircle, plus the perimeter of that same base. So it's going to be this plus a curve times the height. Okay, and the height is always, in these exercises, is given in the word problem. So that's your h, that's your height, which in the drawing would be this here. That's your height. All right, so let's do it. So it would be the measurement of the dimensions of the rectangle is 6 by 5 to find the area. And then remember that the area of a semicircle is going to be the 3 square pi divided by 2 because it's half of a circle. And then the perimeter is going to be adding the 5 plus the 6 plus the 5, because there's a 5 down here that we can't forget, plus the 3 pi. And then times the 10. If we simplify this, it's going to be 6 times 5, 30, and 30 times 2 is 60. And then here is 3 squared is 9. 9 half pi's times 2 is just 9 pi. The 2's cancel each other. You can do it there. 9 times 2 is 18. Divided by 2 is 9 again. And then here, if we add this, is 16. And 16 times 10 is 160. Plus, this is weighted here. And then here, plus 3 pi times 10 is 30 pi. Don't forget, when you simplify, to do the distributive property with the number outside. And again, we're going to add like terms, which is the 60 with the 160. That's 220. And the 9 pi with the 30. 9 pi, which is 39 pi. And again, I just want to leave it like that because that's the exact answer. The units is feet, and so it's square feet because it's area. Okay? Now, this is a very long process, but if you do it with a formula, which you can have in a formula sheet, and then you just substitute all the information given in the formulas, then it's going to be very, very easy. If you have any questions, please put them in the comment and I'll try to answer in another video. Next, we have the surface area of a sphere. And in this case, again, we need a formula. And the surface area of a sphere is very, very easy. It's just 4 times the area of one circle. So 4 times r squared pi. And so if we have to do this example here, we just have to substitute in the formula. The radius is 5. So it would be 5 squared pi. 5 squared is 25, and 25 times 4 is 100 pi. And the units is square centimeters because it's area. Then we come to the last section, which is about sectors of circles. And we also need formulas. So notice that it's all very easy because you can use and have the formulas. So in this case, we're going to talk about sectors of a circle, which is, notice here's the center. Here's one of the radius. Here's another radius. And then this is like just a little part on the outside of the circumference. If we were to close here, we would have a circle. But it's just a part of the circle, okay? Imagine just like a slice of pizza. That's what it is. And what we're going to be doing is finding the area of this. And the formula is, we're going to have something that is called the central angle. And we're going to call it like this: central angle times the radius square pi, which is the area, usually, the formula that we usually use. And then divided by 360, because there are 360 degrees in a circle. And then the same thing for the length of the arc, which is just this part here. The length of the arc is going to be also the central angle, but in this case, it's going to be 2 radius pi, which is the circumference, divided by 360, because there's a total of degrees. Now notice that this can be simplified, so that it is easier just to remember is the central angle, radius pi, over 180. Why? Because we simplified the 360 with the 2. All right, so let's do example B9. It says find the length and the area of this sector. So notice here 45 is my central angle. So 45 is the central angle. And the radius is 10. So we just use our formulas and substitute to find what is the value. So it will be 45 times 10 squared pi over 360 for the area, and for the perimeter or the length of this little part here, this section of the circumference is going to be 45 times 10 times pi over 180, because we already simplified with the 2. So if we simplify that, we're going to get 25 halves pi. And again, this is area, so the area will be square centimeters. And then if we simplify this other one, notice how we can, even before we multiply, we can simplify some of these numbers. For example, I can divide by 10, and I can divide by 10, so I have 18. Then I can divide by 9, and that would be 5. And if I divide here by 9, that's going to be 2. So the answer of that exercise is going to be 5 halves pi. And in this case, it's just linear, so it's centimeters. And that's it, chicos. These are the examples of this lesson, a really long lesson with a lot of things that we cover. Make sure you watch it again if you need to review some of the concepts or the processes, and make sure you write the formulas in a separate piece of paper so that you have easy access whenever you're doing the exercises. All right, work in your practice, and I hope you do very well.